Yeah, am I audible, Anish?
Yes,
Yes,
sir.
yes.
Yes.
All right, so cool. We get started. It's 5 already. And is my screen visible now?
Yes, it's visible.
All cool then. So yeah, good evening to everyone present here today. And today we're going to take the second session of this CFI summer school. And before we get started, a little bit about myself. I'm Tejish, a third year chemical undergrad. I mean CH20, and I'm the current strategist of Team Sahaay. I'm the core team of Team Sahaay. And I'm quite passionate about machine learning and software development. I take care of the software part of Sahaay. I was a coordinator of Sahaay during the last year as well. Wait, yeah, cool. So we'll just look at what we did yesterday. So yesterday we discussed the basic understanding of the steps involved in approaching a problem statement, a detailed discussion on the first three steps of the same, and an explanation of our problem statement as well. And then we had a session with Mr. Madhukar Vaishnav, the founder of Rice Foundation. He talked about waste management, other relevant stuff. So today is day two, and today we'll discuss about the process that involves the generation of possible solutions to our problem statement, discussion of an analysis of possible solutions that we ideated upon, and comparing between them, as well as the last step is a selection of the suitable solution considering all possible factors and condition criteria. And we will also look into the solution developed and finalized by the AWS team. I mean, the original team. So, generation of possible solution. So, this level is frequently referred to as conceptual. Uh, in order to demonstrate how to achieve each of the necessary functions, such as estimated sizes, forms, materials, and pricing, outline solutions are created. Additionally, it entails researching existing solutions for similar issues because there's no point in inventing something from scratch again. Like say, I think this solution would be good for this, and some person had already worked on it before, and he had already made some conclusion out of it. Say it works, say it doesn't, or probably like he had been successful also, so it doesn't make sense to put in valuable time and efforts into it again. So, and just looking to existing solutions helps it. Instead, we could just focus on getting better and more efficient solutions for the same problem statement. So, we should look into the previous existing solutions as well. So, and here, a problem statement is waste segregation. So, which we had discussed in the last session only. Now we'll look at the possible solutions for the problem statement. And these are the possible solutions that could have been done for the specific problems. That is manual segregation, recycling or waste management applications, weight-based sorting, sensor-based sorting, and sorting with artificial intelligence machine learning. And we'll just look into the pros and cons of each solution, like why this solution was considered, why this wasn't considered, in order to select the best one according to our desired specification. And then we'll have a brainstorming session as well, like mini brainstorming session, if you have any other solution in mind. All right, so now we'll just analyze each solution here and see why this is or this is not the best solution. We'll just see both the bright sides of it, and then why this wasn't considered. The part which isn't favorable to our this thing, which isn't suitable for a problem statement. So manual segregation. So this is one of the oldest methods used for waste segregation, and it doesn't involve any tech at all. And the name itself gives up the meaning. It's pretty clear what it means. Manual segregation, man separates. We do it manually. We just separate waste particles. See, this is can. We place it in a can, a plastic can. We place it in a plastic section. This is a paper, say paper waste. We put it in the paper section. So this is what manual segregation means, and the definition is pretty clear. I don't think I need to explain it again, of course. And yeah, but no one is driven to do it because there's no immediate incentive for them to. Like, why do they have to do that? And then the user would become perplexed if there were like too many categories to separate into, according to the second argument. The formation of bacteria and fungi, which can lead to a number of ailments, is especially prone to occur in waste management facilities, of course. So they will be dealing they will be dealing a lot of waste particles, and then the probability of contamination, it's pretty high. So that's the thing. which includes everything from landfills to recycling centers. Many chemical compounds will be left behind if they are not properly treated or disposed, endangering the environment. And this statement was also pretty clear. So the major thing is like getting affected by diseases, and this process is is it time efficient as well, and then the risk of getting affected by disease, that is also pretty high. So people wouldn't really go for manual segregation. And then, it's just straightforward. So what's the tech here? And what's so innovative about it? So that's why a manual segregation, that's all about manual segregation. So do you want to add any more point regarding this? I mean, the pros or cons? Anyone? Uh, well then, so
Even if
anyway,
people
yeah,
segregate at the household level,
yeah.
like there is no proper collection of waste things separately, right?
Could you come again? Sorry. What was your point?
Like even if we segregate the waste at household level,
Mm-hmm.
coming to the collection of the waste, like there is no proper thing, right?
I mean, you're saying like even if it's done at household level, people aren't going to keep it in separate boxes stating this is metal, this is like that, huh?
No, if people will do that, there is no one
Mm-hmm.
to collect the waste, right, in separate man.
Yeah. Right. Got it. So this is a con, right? That's what you meant.
Uh,
Uh, yeah, that's a con. Yeah, of course.
yeah.
So, and anyone else like to add on something? Anish, is there anyone? Is there anything in the chat box? Maybe.
No, there isn't anything in the chat.
All right then. So I guess we'll move on to the next slide. So second solution, so recycling and waste management apps. So even while this method leaves trash segregation up to individual houses or individuals, these kind of apps can offer incentives to users, encouraging them to separate their waste. Like you just adding up to her point only. I mean, so you just collect and keep it in your house, and then you give it to someone, and you get coins or for instance, they could receive incentives based on how much garbage they help separate or recycle. Say I give this much plastic cans, separated, and people do complete rack because they collect papers and metal waste and stuff like that. So it's kind of similar, but then they receive digital cash. So these apps might include knowledge of waste management challenges and guidelines for correct segregation, and that would raise awareness of waste segregation. And this might be improved by automating the segregation process, which would do away with the requirement for manual segregation, utilizing tools like electronic sensors or object detection. So this is kind of like an extension to the previous solution. So here, though, even though the collection is done manually, but then you're just giving it away to people, and then you get something as a benefit. You get some incentives out of it. So this one's a slightly better extension for the previous solution, kind of. And then again, it doesn't involve much, you know, uh, what is it? Tech involved in it, except for the application. And why digital? To just keep track of it, of course. And then it's easier digital. It's easier online. And then it also motivates people to do it. So if I'm getting money for you do see a lot of apps online, get paid for walking, get paid for working, get paid for doing this normal stuff, and then you get paid for watching it. Most of them are scam, but then this could actually help a lot of people. This could you know reduce the effort of a lot of people, and it could make this process more efficient. So anyone wants to add up on this point, this solution, pros, cons, anything? Okay, Anish, just check if there's anything in chat box. That's it.
Yeah, could you repeat what you just said?
No, I just said, told check the chat box if there's something.
Okay, chat.
Yeah, yeah.
No, no, there is nothing in the chat field. Okay,
So,
okay, someone is asking how this idea would be monitored.
how's
Sachin is
the idea?
asking this.
I guess you would be, better, in a better position to answer this question because this was your topic. I mean, you made this thing, this kind of solution. So, could you just answer this question?
So, let me think about it.
I mean, his
Okay.
question was like, who's managing this or this process,
I
or
will, I guess, how will this idea be monitored? Like, maybe
yeah,
who would manage all these things? Okay. Yeah, he's
see,
asking that only. So,
that was something the team, that was something similar to the team which, who's prepared the solution already did something, right? Like
hmm
providing incentives. So we'll get to this part. I mean, when we actually come to the solution, what the team has done.
okay, then we'll come back to this question at that stage.
I mean, something similar was done by the team as well. So consider
Yes,
this
yes,
point.
yeah.
So yeah.
Mhm.
So we'll go to the
Okay,
next
so is
solution.
that fine, Sachin, if we discuss about this at that stage? Okay, it's fine for him. We can go ahead.
Yeah. All right. So here we go. The next solution, and this is weight-based sorting. And again, the name suggests so. You would have seen this somewhere, right? Like, uh, they just filter out rice or some flour. I don't know. I don't really remember. Other than I've seen my grandmother. So some waste particles which may be in some contaminants which might be in the rice. She just filters out by doing this thing. So an explanation of this solution. So ways of many types can weigh the same, and it's challenging to handle if biodegradable and non-biodegradable garbage is stored together at this one location. So I know when attempting to separate waste that is very light in both wet and dry waste, it can be helpful. It can be utilized to aid with manual segregation as well. For example, heavy metallic items and lighter items like paper can be separated easily using this method. And once the majority of the waste has been separated, the last separation can be done manually. So this could be more like an added on solution, but then it can be the main solution for to completely solve the waste segregation problem statement, right? I mean, it can be of the same density, it can be of the same weight, and so weight-based sorting isn't the most efficient thing you could go for because two different waste particles might be of the same way. But then for a preliminary separation, we could segregation, we could use this thing. So yeah, that's one thing. So that was about weight-based sorting, and do you want to ask add up any points to this thing? And it's just check the chat box if there's anything. Yeah.
Like, are you saying the weight-based sorting will be a good one or not?
I mean, it depends on the context again. I mean, you could use it, but then you can't depend on it primarily, right? You
I
could
didn't
use it
get.
for some. I mean, you could use it, but then you can't depend on it completely. So you have to include more sorting processes after this. So it could be a preliminary sorting process. I mean, to just see filter see we're just looking closely at heavy particles, and then just one heavy particle and then a lot of lightweight particles which might be of the same weight. So we're just more interested in extracting the light particles. So first of all, we just separate off the heavy particle. So how do we do that? Weight based sorting, and then we'll just look into the light particles later using different processes.
But I don't think so. It will be a very good one.
It isn't a good one, but then it might be a preliminary sorting, that's it. So if you want something which is light and then there's heavy particles as well, So it isn't the most effective one out there, but then you could use it as a preliminary sorting thing. So most of them would go there. Go out. That's the thing. Instead of having 100% heavy particles and 100% light particles, you could have like say the 80% would be gone with sorting maybe, and then
Okay.
you'd only yeah.
But
So
I
Could be
don't
you
think
can
useful.
just
CFI is a
It could
yeah
be
go
useful
on
to
go.
reduce the load on the manual segregation. So part of it will be done like by weight-based sorting, maybe automatically, and the rest waste can be done manually. So it kind of reduces the load there, but overall it won't be that efficient.
Yeah, that's the thing. See, so the point is like you can just depend on it entirely to segregate all waste particles. That's the thing. Hope that was clear. All right. So anyone else? Check the chat maybe, Anish.
There is nothing in the chat. And just one point from my side regarding this. So we
Okay.
are just going through all these solutions. Like maybe when we look at a solution, it won't be ideal for the overall sorting, but we must go through them just so that we know why we should not use this kind of method. So for that kind of analysis, we must go through these types of methods also, like manual segregation or weight-based sorting.
Right. We're just going through all this existing, we're just going
Mhm.
through all the solutions which came to our mind, and then we'll just seeing why this wasn't considered, why this was considered. So, that question just pop in your mind. Why this and why not this? So now we're looking at why this or why not this. So we'll just look into the later which one we consider. And then, so yeah, we'll just go to the next slide. So the next one, sensor-based sorting. So how this works, I mean, this one's also, the names gives it all. I mean, that's quite easier to understand what sensor-based sorting means. So first, the garbage is detected by sensors, and then it can be divided into metallic, dry, and moist waste using various sensor types. I mean, the metallic sensors, dry and moist can be separated using humidity sensors, moist sensor and stuff. And inductive sensors that can be withdrawn magnetically can be used to remove metallic trash. To just magnet kind of thing. That's it. Although moisture sensors can be used to distinguish between dry and wet waste, their accuracy may be limited because they're primarily designed to measure soil moisture rather than waste particles. So this one's accuracy it might not be up to par. And yeah, because these are designed to measure the soil moisture, not to check which ones wet waste and the other which ones are dry waste. So yeah, that's one drawback. And then the sensors have their own drawbacks. They have their own set of drawbacks, such as restricted range, of course, again, and then their ability to detect just certain sorts of materials. So this technology is superior to manual segregation and weight-based segregation. I mean, this has relatively more perks than manual segregation and weight-based sorting or yeah, other recycle lab thing. But then this is again limited. I mean, we can just depend on it completely again because we have various factors like a range, and then we can just categorize everything here. So only a few categories we might categorize here, and then the rest will go into the same thing again, and then we have to categorize it. Again, we can use it like how we use waste segregation, like a preliminary elimination kind of thing. So that's how we could use sensor-based sorting, but then again, we can just depend on it completely. So yeah, it's got its own share of drawbacks as well. So any questions or like do you want to add up on this? So yeah, Anish, anything in chat box? Nothing over there. Okay. So That was all about sensor-based sorting. And then next thing, so this is AI and machine learning-based sorting. So here, how do we do this? Again, the name gives it all, like what it does now. And by employing object detection and image classification algorithms to separate the waste into a variety of different categories, such as paper, organic waste, metal, plastic, and etc. We can just segregate any form of waste at the source level with a very high degree of accuracy. So we're using machine learning and computer vision technology. So the accuracy is going to be higher if we implement better algorithms. Compared to sorting using sensors, this one's of course this one's more accurate because that one's got its own share of range problems, and then we can just categorize into a few. We can just the categories are limited, and then its accuracy is good, but then the categories are limited and it's got its own share of drawbacks as well. So compared to sorting using sensors, manual segregation, and all this methods we discussed before, this one's of course better than the previous ones we discussed. And this might be difficult to create a reliable bin using AI and image detection. And it might be expensive to produce and maintain. I mean, maintaining, of course, again takes time, and the camera should be placed with perfect in position, and then you're leaving it out in the open, and then people might that maintenance problem, and what if rain shows up? So those problems are all there. And then detection, again, we should take care of that as well. So what can be done? Can be employed in public areas, and it can be managed by a variety of parties, including store owners in malls or shops. I mean, you can just place it outside a shop, and then you can just expect people to throw waste there, and it's sorted, and people get some incentives as well. So we can consider that idea as well, like integrating the recycling app which we had discussed before, and then this thing here. So we could do something of that sort, and then compared, you could see it clearly compared to previous sensor previous methods. This one's more efficient. And one more integration also we can do here. So after the sensors method, we can just redirect to this. We can just connect the sensors method and then the AML based sorting. So yeah, I heard someone unmute. So do you want to add up or ask any question here?
Yeah, like household waste is more, right? How can we manage that with these type of things?
I mean, this can be put in a public place. So again, this one's what the team had considered. So what they did is we just place it outside, place outside a mall or a restaurant or somewhere outside.
Okay,
So people go there, throw the waste, and then it gets segregated. And yeah, that's it.
okay,
So it
okay.
can be helpful for the recycling parties as well. So instead of spending money, first segregate it and then taking it outside.
Here, not only the shop owners, but the a community of people also can manage it, right?
Yeah, they can manage, but then placing it outside a shop, probably a restaurant or a coffee shop, it's more beneficial for the shop owner as well. But then yeah, your point is also valid. That's what I
Yeah,
ideally
how
suppose.
can only the shop owner manage it?
I mean, what your point said was like how they manage it completely, but then I'm just saying like shop owners can manage it. I mean, they can keep it outside and then
Okay, 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 I
yeah,
understood.
yeah. So, any more questions from this, or do you want to add any points here? Anish, could you check the chat, please?
Yeah, there are no questions in the chat.
Otherwise, like it can be set up for a ward. You know wards?
Could you come again? Sorry.
Like, do you know what I meant by wards?
I don't think so. Could you explain what you meant?
Like in a municipality is divided into wards, right?
Okay.
We can make aware of people. We can make people aware of this thing, and we could take their help to manage the bins.
Yeah, we
Right.
can
Yeah.
do
That's
that.
also.
uh,
Yeah.
or possibly on a bit smaller scale, like for example, in some housing societies, maybe they could purchase two or three of these and manage it inside the society so that everyone is putting their household waste in this kind of a machine, and it gets segregated. So we could do that kind of a thing also. But at a world level, it may be the amount of
Possible.
waste may be a lot, but at a level of some housing society which has three or four buildings, it may be a smaller scale than that. So it would be manageable easily.
So, and then, there's one more thing. So, in order to make the accuracy high, we got to check about different algorithms and see which algorithm suits our thing, and then we have to categorize, we have to train the train the model as well using data sets. And yeah, we should maximize uh, the accuracy. Else, there's no point in making this using AI and machine learning. So, of course, it's a better one, but then, maximizing the accuracy is our main goal. So that's why we're considering this one, and it's automated as well. So that's another point. So I guess we'll go to the next one. So this is the next step. So selection of a suitable solution. So the numerous solutions are assessed. I mean, the solutions which we had discussed before, considering the problem statement. So we discussed about manual segregation, weight-based sorting, and then recycle apps, and then this thing, sensor sorting, and then machine learning and AI thing. And then the best one should be chosen. I mean, we have to collect all those ideas which pops into our mind. I mean, we have to analyze each one of them, and then we'll just have to compare them and just see which one's better, which one suits our thing. So in some cases, sensor based might be useful. In some cases, AI ML might be useful. We have to consider all possible constraints and all possible, you know, situations we are using this under. So that's how the best solution is chosen. So the effectiveness with which we are able to address the problem in the best way, it should be feasible as well. That will be evaluated together with the product's user base, and then we'll land up with end up with the final solution which we're going to consider, and then we'll go on to the next steps. So that's how we analyze this thing. So from now on, Tejas will take on.
Just
Thank you.
one thing before that.
Yeah.
So like here we have discussed some five different solutions which we thought of. So is there anything from you guys, like some possible solution which you can think of? And maybe we could have a small discussion on that before moving forward.
Yeah. Any more solutions other than this?
And then we can go to the comparison of all those solutions. Can have like 5 minutes for that or 3 minutes for you guys to think about it. And if there isn't anything, we'll just move on.
So can you please repeat?
No, we're just asking if you got any other solution, any other idea, apart from the ones which we have discussed right now. And we can just
Okay.
have a discussion on that as well. If that why this one is not feasible, what could be the pros and what could be the cons as well. So yeah,
Okay.
we just give you 5 minutes, maybe just think on it, and then we'll just discuss and we'll move forward. Yeah. Yeah, I guess we'll just start at 5:38 maybe. We'll just give some more time for them to think. All right. I guess it's 5:30. Rani, let's just check if there's any solution. I mean, if there's something on the chat box.
No, so there isn't anything in the chat box, but if any of you guys would like to speak up, if you have anything, any solution, then we can discuss about it, or else we'll move ahead.
Yeah. You can just put it in the form as which will be circulating after the session. I mean, if you have any ideas which we could consider. So yeah, I guess that's it. Yeah, I guess Tej will take over from now. Thank you. Yeah, Tej, where are you? Hello, hello. You aren't audible. You aren't audible. No, you aren't audible. No, try changing your microphone, maybe your Bluetooth earphones, maybe something. You aren't audible at all.
Am I audible now? Hello.
Yeah, yeah. You're audible now. Perfect. Start sharing screen and yeah.
Okay, it's visible, right?
Yeah, it's visible. Perfect.
Yeah, so moving on to the next part. Actually, we have analyzed the possible solutions as of now. So the next important thing is selection of the suitable solution. For this, we need to compare the solutions we have analyzed. So let's move on. The first one is manual segregation. As we know, at source level, like in household and all, there is no immediate motivation for people to do this kind of stuff. Like there is no immediate incentive and all. But at a larger scale, segregation by manual segregation is unhygienic, and the conditions for workers involved in the process of manual segregation, it's awful for them, and it's not comfortable for them to segregate a large amounts of waste into different kinds of into segregation and all. It's hard for them, and it's very unhygienic. So manual segregation is a bad choice for segregation of the waste. So next one, recycling apps. The lack of motivation in manual segregation, it is provided through apps like incentive based systems and all. It is provided, but it still have to be done by people, which does not ensure the proper waste segregation. Like, it's not that effective when compared to the automated system. And we can consider this also as a suitable solution. And like in large amounts, it's obviously not a suitable solution. And the next one, weight based sorting. As the name suggests, it segregates the waste and it classifies it categorizes the waste based on its weight, but it's very less effective. Even though it's a most cost effective one, the accuracy is very low considering the level segregation. It could be useful in terms of large amount of waste, but it's not that effective. If the difference of weight between the system, like between the particles, the waste involved is more, we can easily separate. So it might be helpful in a larger scale. It's not that effective in a household system and that source level. It's not that effective because the biodegradable waste and non-biodegradable waste, they can have the same weight, so it's not that accurate, right? So it may not be the suitable solution, but we can try it for the larger amount of waste. uh, the next one is sensor based sorting. As the name suggests, again, the sensors are involved and they are used to predict the waste, and they can categorize, but it is not much effective because they cannot categorize much amount of waste. Like every type of waste cannot be segregated. There are many limitations for this process, but again, this type of method could be useful to separate like specific type of waste, such as metallic waste, which could be in larger quantities. Like this can also be useful for the larger quantity of waste, but not that effective at source level systems and at households and shopping malls. This is not nothing much of a better idea. So uh do you guys think sensor based sorting is better? Like it cannot involve the maximum number types of segregation methods. And next, moving on to the next one, AI, artificial intelligence, and machine learning based sorting. This method provides the highest accuracy than any other discussed methods. We can personalize and we can customize the type of waste that is being segregated. And but the problem is, its overall cost of the segregation is very high. Its maintenance cost is also very. Do you want to say something? Hello, can you hear me, please? Hello, anyone want to say something? Okay, so even though this provides the highest accuracy, this is not much cost effective, but still we can use by maintaining the cost, we can manage. So this can be a suitable solution for our problem solution. So anyone want to add up some comparison between these uh, discussed problem solutions? Anyone? So, guys, if anyone wants to share your thoughts, you can just speak out. Otherwise, you can mention in the chat. Let's move on to the next slide then. So, uh, moving to the next part, it's not like the processes which are mentioned in the design process, they are in the order. They are not, they just not flow on stage by stage. There will be often need to return to the earlier stage and give further consideration. Thus, like sometimes we have to go back to the earlier stages and we have to analyze again. Sometimes we have to go to the analysis part and we have to analyze the solution again to get the correct solution. And sometimes we have to go specify things. We have to go back to the specifications part and we have to specify what we need and all. So sometimes we can go to the previous parts. It's not like every time uh, we'll be going on a flow in the process. Sometimes we need to go back and we have to continue the cycle again. We have to come back. So we'll be often returning to the earlier stages and give further consideration. Sometimes we have to reconsider our analyzing part and we have to reconsider our specifications that we have made earlier. So yeah, and this is how it happens. Sometimes the need analysis of the problem, preparation of the specification, and then generation, and then selection. Before creating the production of the design, we have to sometimes come back to preparation part, preparation of specifications, and sometimes we have to come back to analysis of the problem. Sometimes we have to come to the generation of problem solutions. Like we can get new ideas in this way, and the design should be unique. Like we shouldn't make the old idea again. So we have to come back to the previous processes and we have to analyze again. So the next part is the proposed solution. Now after we already have analyzed, we compared all the solutions, the possible solutions. So the most effective one is AI and ML based waste segregation, because in that we can customize the segregation parts, like the different types of waste we want to segregate and all. So let's see how it works. We can make a bin that will consist of some n section to segregate the waste into n categories. Like we are making n sections in which it will detect them into n categories and it will be dumped into n parts of the respective parts of the bin. So we shall use camera for image capturing and waste, and then that will go into the algorithm. Like we will be knowing how it works in the later on part. Like this is to give a basic idea for you all. We shall use camera for image capturing and all, and then the part that receives that will go into our algorithm, and that decides the category of waste in which it have to be dumped. And then a mechanical system then put the waste in a specified section. It will be most of that will be covered in the mechanical part. So, and then to this is the proposed solution. As far as we know, we can make changes and we can go back to the previous steps as I have discussed earlier. We can go back to the previous steps as discussed earlier, and we can reanalyze and recategorize and specify the things we need, and we can make the model as we go on. And then to encourage the use of this bin, we have to come up with an economic model that will make sure that we are able to generate like uh, this is a high cost maintenance system as we know. So for to get profit and all, like to recover the money we have spent on the system, we need to make such a model that requires, that helps us to regain, like, people won't be doing such things without the profit and all. So we'll be recycling the waste, the segregated waste will be recycled, and this will be uh, helpful to gain money and all. That this and all will be analyzed in the economic model. The revenue generated from this will be used to provide incentives to the users, like from this in the form of digital money or something else similar to this. So in this kind, we will manage to recover the money, and the revenue will be generated in the system, will be used to provide incentives to the users again, so that people will encourage to use the bin more and more, and it will be working in many places. So moving on to the next part, production of a detailed design. So we will be selecting a design and we will work on it. We will make working drawings, we will make circuit diagrams, we will make 3D models using modeling softwares and all. And then this gives a basic idea on how the product works, and we will make, like, continue to make the physical model based on this idea, like making working diagrams, circuit diagrams, and 3D models. This will give a basic idea how the model works, so that production of a detailed design, it is the most important part. So moving on to the next part, production of working models. This is the part in which we'll see our result. So actually we have already made the 3D design, which gives the basic idea, from which we'll start making the physical product. So this might require the production of prototypes or mock-ups in order to determine the optimum details of the design. So sometimes after making prototypes and all, we need to make some changes, for which we have to go back to the previous steps. We will make changes in the 3D design, and we will make changes in the physical product until we obtain the exact product which works in the way we have to, for the in the way which contributes to the problem statement. So production of working models, like, it's basically based on the design we have made. So this is the most important, like, production of the design is very important part, which contributes to the making of the physical product and prototypes. So moving on to the next part, yeah, we have worked on the system. Our team is one of the only teams from the 1 lakh applicants to reach the Singapore finals of the 1 million hull prize. So this is the proud moment. We have gone on. It's only one of the 50 teams from 1 lakh applicants. So these are the articles which are printed, which are published on Chennai Times on 13 November 2017. So carry on. These are the articles. Moving on to the next part, design of the AWS. As we have discussed, we have to make a nice design 3D model, and we have to implement the making of the physical model, which requires the following 3 modules. The overall design that can be divided into 3 modules, basically mechanical module, and the electrical module, and the programming module. So let's move on to the mechanical module. This module is the most important one, as this gives the physical model of the product, in which we have to use the electrical part, and we have to use the artificial intelligence and machine learning part. So this module is concerned with ensuring that waste is directed into correct compartment. Like, in we have to design some end compartments, and we'll be analyzing that end compartments, we'll be segregating using the electrical part. But for this, with this mechanical module, we will be making compartments, and we will ensure that the waste is directed into the correct compartment. The bin will consist of 4 compartments as shown for each of the waste category. Like basically, we are taking 4 compartments. To move the waste into the appropriate bin, a 3/4 of this with a brush is used. Like we can see in the model, like I'll show the video. See, there is a 3/4 of a disc and a brush, which ensures. Can you guys see it?
Yes.
Yeah.
Yes.
Yeah, I'll play it again. So the disc will be rotating. In the process, the waste is categorized in which compartment it should be dumped, and then the brush will rotate to ensure that the waste will fall in the compartment in the provided space. So see, both the disc and brush are rotated by motors actuated by L298 and motor controller. And then once the waste falls on the disc, it rotates so that the empty portion is aligned over the correct waste compartment. Like the disc, it rotates and such that the empty portion is aligned over the correct waste compartment. And then the brush rotates, sweeping the waste into the compartment. So as we see, guys, first the disc will rotate, which aligns the compartment in which into the waste should be dumped, and then the brush rotates, ensuring the waste will be falling in the correct compartment. So this is the contribution of mechanical module. So the next part is electrical and sensory. This primarily deals with the control and sensory information of the various parts of the prototype. Like from the prototype we have obtained, it will be
Excuse me.
dealing with the, okay.
Like in the mechanical one, first the disc will rotate, right?
Yeah, first disk will rotate.
Then the brush will be rotated. But how the waste is going to be separated and the brush is going to remove it?
Like as soon as the waste falls on the disk
Okay.
initially the disk rotates such that it aligns over the correct waste compartment. Like
Okay.
the empty space will be aligned on the correct waste compartment. And
Okay.
then the brush starts to rotate, which sweeps the waste into the compartment.
Okay. Okay.
Okay. And then moving on to the electrical
Have
part.
we made the categories of the waste?
Yeah. Can you repeat it again? Can you please repeat it again? Hello?
Have we made the categories of the waste? What are the parameters that should be considered while quantifying the waste through AI or ML?
I didn't get you.
Am I clearly
Your,
audible to you?
yeah, it's not exactly clear. Can you repeat it?
Am I audible?
Yeah, no, it's fine, I guess.
Um, we are talking about the separation of the on which parameters we have to depend. Actually, we should apply some parameters to AI and ML. Correct? Yes.
Yeah, the
So,
algorithm will be fixed
so
in the electrical and sensory part. Yeah. Continue.
what should be those parameters?
Yeah.
image based processing, or the specific gravity of the waste, or which kind of parameters we are going to choose
For
Oh,
It is
for
going to
for
be
the
classifying,
segregation of waste.
for segregation, it's based on computer vision primarily. So yeah.
Have you understood what point I want to explore? Which point I want to explore?
No, he was just asking which, how are we gonna classify, segregate the waste. That was your question, right?
Hmm.
So we use
What
computer vision to
parameters
segregate.
we should consider?
What parameters? I mean, we have a model trained, and we have a model trained, and then we implement CV model, and then we just segregate the waste. That's it. That's how it works. So we'll
Okay.
just explain how we implemented the model, how the code works in the later part, maybe. I mean, during the programming part.
The problem is waste segregation because our 90%, even the more than 90% of the funds are just we are wasting on segregation and transportation of the waste. And for the treatment of waste, we are not getting anything, any funds. 90% तो हमारा segregation और transportation में use हो जाता है सब. Treatment के लिए there is nothing available. So uh, this is a huge challenge in India. And one more thing, India में सबसे बड़ी problem ये है. Are you all comfortable with Hindi, or we have to move in English only?
It's better if we keep it in English only. If we stick to English only, because
Okay,
I'm not
okay,
pretty sure. Yeah.
okay. Actually, I forgot the point. You continue.
Let me take it. So, like in this case, we are trying to segregate the waste by the image processing mainly, and then in the electrical part, there are some sensors, so that can categorize in some category, but we cannot wholly depend on that on totally sensors. So we are using image detection part as well. So I think this was your question.
No, this was not my question. I know these things like, by the help of image processing or the help of any other parameter, we are going to separate the waste. One more thing. If we are talking about waste in India's context, there is about 60 to 70% MSW, municipal solid waste. While we are talking about US and the developed nations like France, they have only 10 to 20% MSW waste. So, uh, if we talk about the revenue from this waste that we are generating from India, so revenue portion will be quite less because MSW won't give you much revenue as compared to the other waste can give you. Am I right?
Yeah, that's true.
You agree all, or you don't agree? MSW portion is
That's
very much high in India.
yeah, true.
So because we are going to implement artificial intelligence and machine learning based instruments, and that cost really cost very high. And other things, the cost of maintenance would again be very much high. Cost purchasing cost is very high. Cost of maintenance because these are machinery parts. So cameras and the image processing units. This may be require very high maintenance in terms of economy. I'm telling you. So uh, can we do one more thing before reaching the waste to AI ML based units? We can also process the waste through the above mentioned steps what steps uh, we were just comparing, just like weighing. So before AI or ML processing units, can we introduce those units too, so that our processing would be quite accurate? Have you got my point?
Uh,
Can we introduce?
yeah. So the point is like if we are introducing them as
Please,
well,
Professor.
then hello.
Yes, yes, you are audible, sir.
Yeah, yeah, yeah. Okay. So if we are introducing them, then why we are keeping this? So this AI based thing is doing all the work, right? And we are not doing it at a larger level. Like it's a source level thing we are doing. So introducing multiple things will increase the cost way more. Yeah, we can think about that. We are just using them, but again, then the accuracy will go very less.
If we sort some waste through weight, let us suppose some is biodegradable, some is non-biodegradable. On the basis of their specific gravity, weight, if the weight is on the belt, further moves towards the AI and ML unit, this will give us more efficiency.
Yeah, I got your point.
Because
So
by introducing 1 or 2 units extra, we can save a lot of money. Uh, that is that we are going to spend on the maintenance of AI and ML units. That we can save.
okay, so I got your point. So, like in this case, we are not doing it at a large level. So it's more like that we have a collected base from all over the city, the thing you are saying about, and then we are trying to segregate that. But here we are not doing that. We are making bins. So that's the point. But that's true that if we are going to apply AI and ML at the at bigger level, uh, where we have collected waste from all over the city also, then we have to consider different things. That first we might segregate the waste on the basis of their weight, so that we could categorize some heavy metals thing or paper plastic things, so such as, and then we can also include the sensors as well, so that we could categorize some wet things and some dry things. So and then we can introduce the AI part to make it the final segregation. So that would be at a bigger level.
Yes, yes, yes.
Right, that's true.
My point is the same that you have explained.
Yeah, right.
And can we do one more thing, because all these processes basically requires money a lot. Okay, can we do segregation at the source, in the sense, why collecting waste from the residents or from the industry or from the commercial institutions? We can, if they are giving us commingled waste, we can penalize them, or we can refuse, we are not going to take your waste. And if anywhere um, you were detected to throw your waste, you will be penalized so much. Just like this, can we
Yeah,
do?
yeah, that kind of thing like can be thought of by governing people. But the point comes that if we are going to penalize it so high, so either they will do it, or else what can happen, they will try to put waste somewhere, so they'll not give you at all. So this type of thing can also happen.
We can put cameras everywhere. As per government, not I'm not saying this as a researcher. I'm saying this
Huh.
just like governing bodies do. If we do things in this pattern, we can save a lot of money and because commingled waste requires a lot of money and obviously the proposal given by you is quite good even though it's very good but I am just telling you the revenue generation by the waste is always less and in case of India it is very less.
Mhm.
You think uh, you can generate a lot of revenue from waste, it is waste of our energy. I think so. But because after 2014, after implementation of Swachh Bharat Mission, we are just going to think about these situations after 2nd October 2014. Before that, it was you please continue. You please continue. Nothing.
Uh, I couldn't get your last point. Elaborate on that.
Actually, I was telling the about the revenue from the waste because we are investing a lot. We have to
Mhm.
cover the waste produced by 150 crore people, not
Mhm.
for 1,000 people, for 2,000 people, 5,000
Right,
people.
right. True.
Okay. Actually, what we are doing, we are producing commingled waste, and it is very unhygienic to separate these waste by some laborers appointed by the governing body
True, true.
or by machinery. It takes a lot of money because machines, the cost of machine is very high. The cost of purchasing cost as well as maintenance cost, both is very high. So
True, true.
what we can do, we can we can force our government kindly penalize the people who are giving commingled waste. We can segregate the waste at source only because 90% of the funds given to the company for the treatment, segregation, and transportation. There is a lot of wastage in India. So
Hmm. True.
we can do one thing. We can do one thing. If you give metal waste or electronic waste, we can take your waste free of cost. If you give us biodegradable organic waste, we have two types. One is biodegradable fraction of the organic waste, other is non-biodegradable fraction of the organic waste. If you are giving us these two waste separately, we can take we can take that waste free of cost. No problem is there. But if you are giving us commingled waste, we are going to charge. What do you say?
Yeah, true. So these kind of policies can be implemented by policymakers. Uh, yeah, that's true.
Please continue. Actually, I have some solutions too. What we can do with the biodegradable fraction and the non-biodegradable fraction of the organic waste, organic matter provided by the residents. But again, they are basically uh, basically a lot of money we have to invest. So this will be fruitful only when we are going to treat a huge quantity of waste.
Yeah, that's important. That's why we are doing segregation, right? So that we could create that.
Okay, please continue.
Is that all?
Yeah, this is all from my side. Please continue.
Thanks. Rajesh.
Yeah, guys. Uh, in the electrical and sensory part, like this is primarily deals with the control and sensory information, and then to enable the composite feature extraction, a miniature camera, an inductive coil for inductive sensing, and then capacitive plates for inductive sensor are used. Like these are the main parts, and some of the common components like L298N motor controller, like it is used to control the motor that is putting waste in different sections. It's primarily to control the motor, uh, which helps to put the waste in different sections. And then some other parts like IC7414 based skim trigger is used. That trigger is to exclude the noise of the signal coming from the sensors. And then power management and low capacitance measurement are handled using these components. So basically, this is the electrical and sensory part, and then deep learning and processing section. This is the main part because this ensures the detecting of the sensor. Like whenever the sensor detects the entry of waste, camera present inside the dustbin that clicks images of the waste, and then the pictures are processed using the faster RCNN, and then it is classified into the four categories, which we initially divided into four categories called metal, plastic, glass, and organic. So the pictures are used and processed, and the waste is detected as metal or plastic or glass or organic, and then it is sent into the respective that section in which the waste to be dumped. So this deep learning and processing section is the important part, while the others are also important. So whenever the sensor, like it basically works on the on our idea, like the sensor
Uh,
detects the waste using the camera and the pictures are processed, and it will be
Hello.
categorized into the required waste. Yeah.
Yeah, like only using the pictures, it will categorize the waste.
No, that pictures are being processed by cameras, and then we will be using the algorithms, and then it will detect the waste into the required parts, not exactly using pictures.
Okay, okay, thank you.
We have
So
to introduce some more parameters, not only pictures.
yeah,
Okay, sir.
so these three modules basically consist the design of the system. This is to give a basic idea on the how the design works. We shall be learning more about the working of electrical, mechanical, and the sensory part and the deep learning part in the next coming sessions. So we'll be also discussing how the sections work. We'll be discussing the basics of Python and machine learning to get an idea how the parts of the sensory parts will work. So now, anyone wants to say something? Uh,
We have to use one more software to learning these objectives. That is Schema Pro.
yeah,
Along with Python, along with AI and ML, we have to learn Schema Pro too, just to get
yeah,
the
like
kind solution. Yeah.
yeah, the softwares and all we'll be discussing in the later on sessions. So now, is there anything to say?
When you are
Any
going to organize the next session,
uh, Tuesday?
Tuesday. Okay. Actually, uh, Actually, our semester exams are going on from Tuesday onward. So,
You will get the record. Yeah, like this program requires 80% return. So if you miss one session, it won't be much. You will get the recording also to catch up with the next session. Is it
sure.
okay?
Thanks a lot. Thank you.
Yeah, and Anish will be carrying the later on part. Anish?
Yes.
Yeah, I guess there's one doubt to address. I mean,
Mhm.
if you had to address it, right? Yeah, Manish, go on.
Okay, so there was a doubt in the chat in the starting part. So, who will manage the waste recycling apps? So, for that, first, I think we can discuss what kind of an incentive model was used by this automatic waste segregator team. So, what they had done is that they installed their system outside the cafe in the campus of our college, and then whatever the waste was collected, the part which could be recycled, they decided to sell the recyclable part so that they can get money out of it, and from that money they provide the incentive to the users of the users of the product. So, for example, if they are implementing this outside the cafe, they may provide the incentive in some form of points which can be used to buy things inside the cafe. So that kind of a model was used by the team. So, like if the waste is being collected by some person or some private organization, the app can be managed by them so that they take care of the selling the waste and as well as providing the incentive. But if it is managed by some municipal corporation or government bodies, then they will be the ones who will be responsible for this app and providing the incentives. So hopefully this answers the doubt. I think the doubt was asked by Sachin. Okay, so is this fine? Okay. So, yes, she said yes in the chat. So we'll move forward with the session. Just share my screen. So is my screen visible?
Yes.
Okay. So now we have covered the, like we can say, the first step in a product design, which is the design process. Like we have covered the basics of that and looked into the different steps involved in that. So now we'll go into the technical requirements which will be required to design a product. So you can break it down into mechanical, electronics, and software module or a programming module. So first we will start out with the mechanical module. So today I'll be just giving a brief about this module, like in 15 minutes. And in the next session, which will be on Tuesday, we will go into the technical parts of this. So as you can see in the slide, these are some of the designs which we have used in our projects. So at the top left, this is a design which was made for the automatic waste segregator, and other things on the right are just some of the designs for our other projects, and this is just one crank slider mechanism design which can be made in Fusion 360. So mostly the software which we use for the 3D designing in the mechanical module is most commonly it's Fusion 360. We'll come to that in a few slides. So why 3D modeling? Why is it required and why do we want to do it in the first place? So 3D modeling is generally used before the actual or physical prototype is built. So there are some advantages of doing this process before directly going to build the physical product. So it will help us to visualize the product better, and at the same time we can get some insights about some of the physical challenges involved in the building of the physical product. So those kind of things can be caught earlier in the 3D design part itself. Also, changes can be made easily in the 3D models. So, if we directly build a physical prototype and then we need to mix, we notice some errors and we need to make changes in it. It's a time-consuming and energy-consuming process. We need to build those things again, maybe. But in case of a 3D model, it's using any software, it's easy to make such changes. And so by making such changes, and if we come to a final 3D model using any software, then it would be pretty easy to just follow it and build our physical product. And also in some cases, we may require to print 3D parts for our assembly. So for that, the detailed model of our parts is important so that it can be properly 3D printed. So some of the common 3D modeling softwares are, some of them are Fusion 360, SolidWorks, and AutoCAD. So we generally use Fusion 360, and for students also it has some advantage. So any doubt regarding this till now? Any comments? Anything from your side? If there is nothing, fine. So about Fusion 360. So Fusion 360 is one of the most popular 3D designing software used by students. So for students like who are currently enrolled in any college, they can download Fusion 360 for free using student license, for which they just need to submit, I think, any proof which shows that they are associated or affiliated with that institution. So it's free to use for students, and even though it lacks some features which are present in other softwares, say like SolidWorks, it is simple, user friendly, and so it's actually free for students. So these advantages, due to these advantages, it is very popular, and we will also be using the Fusion 360 software to demonstrate the 3D models in the next session. And also it provides a cloud-based storage system for the files so that it can be used collaboratively and different people can access the files through cloud storage. So yes, that is about Fusion 360. And in the before the next session, I wanted to tell you guys that you need to download Fusion 360. So you can just search it up on the internet, like download Fusion 360. Go to the website. There will be some option for student license. If you go into that and enter your details, college email ID, some proof of you being in that college, then you will be able to get the Fusion 360 license and you will be able to use it free of cost. So this is one requirement before the next session, that you must download Fusion 360, because we'll be demonstrating some models to give you a basic idea about Fusion 360, and then you will have to do some tasks to uh, learn Fusion 360 on your own and get familiarized with it. So this is it for today's session. In the next session, we will go into the 3D modeling with Fusion 360. So are there any doubts right now?
Sir, on Tuesday, at what time you are going to organize the same?
5 to 7, the same time. So if you are not able to join that session, you could also take a look at the recording if you want to, or the slides which will be presented. But the problem is that for at least for the mechanical module, there won't be much of slides, because it will be like we'll show you how to use the Fusion 360 software, and for that we'll just use the software and not any slides. Yes. Anything else? if there isn't anything else from your side, maybe we can end the session here for today. Is that fine?
Yeah.
Yes, sir, we can.
Okay, then we'll end the session for today and we'll meet again on Tuesday.
Yeah, at the same time, 5 to 7 on Tuesday. So, yeah, that's it. Thank you guys for showing.